My name is Ferruh Yigit, and I'm working at AMD and working on DPDK for some time now, and I'm currently a NextNet maintainer as well. So I will talk about a little ABI versioning, and the target here is create some reference material for DPDK developers. So this is mainly for DPDK developers. And at the end, I have a related discussion topic if I can make on time, which I will try to be a little quick here or there for this one. API in our context is between DPDK application and DPDK library, shared library. Otherwise, there's no concept of ABI anyway. And very simple, crude example. Is it visible, viewable, understandable? Not too good, but yeah, I will try to skip these things. But normally we have a struct. This is, we know we use in TX configure, and this is whole output of that one. There's a API using it, and there's a function call from application. But eventually, when we compile, it turns into just address and a fixed number added to it. So at that point, library has just numbers, application has just numbers. If you want to set queue state, offset plus some number, some value. And because of the contract between application library, they know where to find where. That works fine. But my point is, and I will come to this one, at binary level, there is no fields, structs, etc. And normally, no issue with the binary interface, but it becomes problem if we change the shared library. If we switch from one to another, if the ABI is not compatible, that cause trouble with the user application. And we are caring for users, and we want to make their life easier. That's why we are trying hard to have a stable API. But we let it break once a year, like in the movie, The Purge, maybe. But yeah, mostly we try to keep a stable API. Now, let me show you how it can be a problem. We said when library changes, and if ABI is not compatible, it will be a problem. In trying to have a stable ABI slows down us a little in development. So this is very, very simple. Anything I can do simpler. We have an application called function for, and it has two arguments, which just accept up and returns. We run it, it gives correct, great. Then I changed update my library. Now it gets 3 parameters and does another logic. Can I run my old application with this new shared library? Normally, there are mechanisms to prevent this, like so name and versioning, but assuming that they are not there, yes, I can run. The binary can find the new library, but result is unexpected. That's the problem. So because of the ABI change, the contract is broken now, so that will give just wrong. If I compile my application again, of course, fixing the for with the new library, that will work fine. But my point is, it may run, but give wrong results if ABI changes. And that's, as I said, I will turn back here. This is a previous struct, a new field called new field added there. The whole output is changed, so the memory layout is changed. Now my queue state is in a different address. So what happens now? Library, when does the math, finds a different memory address because now it used 62 as an address for the queue state, but the application still used the previous one. That's why, again, contract is broken, ABI interface, the interface changed. Library may set a correct value, but what application reads, since it's reading from wrong address or different address, will be completely wrong or something different. So this is, again, a very simple display of what's going wrong. If this is causing problem, why we are changing DPDK library versions? Let's stick with 2.2 or even 1.8 from 6 years ago and keep using it. But now, of course, DPDK will get updates, and we want to reflect those updates. So, and of course, for new features, we need them. And other thing I said, if we compile the application with the new library, that works fine. So why not do that? And again, that's an option, and probably many users are doing that. But if you are using a binary distributed application, that's not an option. You didn't compile it at first place, or if you are using a Fedora Ubuntu package, again, that's not an option to compile from scratch. So what are our options? One thing, don't break the ABI. That is one option. Some projects prefer to not change the function at all and keep adding new ones. So we may not break anything, but then it will be difficult for users. So it will create a mess after some time. And we cannot make code correct at the first time, or it may be correct at that time, but things change, application change. So we have to update our code. So it will be necessary to break it. Or we can wait for the ABI breakage release at the purge moment. That is an option, but again, we are doing it once a year. So sometimes it is too much to wait. So I just want to talk about perhaps there is another option, not perhaps there's another option. We can utilize more in symbol versioning. That's in DPDK we are mostly referring as ABI versioning. And it is already used in DPDK in multiple times. I have a reference slide at the end. I put each commit IDs of those, so it can help people to go and check what they did. But basically, what symbol versioning is having two versions of API in same shared object. So, and dynamic linker helps you to find the correct one. That is supported by ELF and bin utilities. Existing, the old application will be able to find the old APIs. New ones will, when you compile them, use the latest one. So that, in theory, that's simple. And there are multiple ways to get that information from binary. Objdump, readelf, NM, I think all three shows that. I used readelf here as a sample. From LS binary, if we check, we can see three. I just picked three, not on the tree, but at least these three APIs using some version of glibc. So there's a tag for glibc. glibc is using this a lot. I think it is obvious that it is distributed a lot. It should support multiple binaries. And when I do the same with the SO, glibc SO, I just get a sample of clock get time. It provides two different versions of it, but there are a bunch of it in glibc. Here, the difference notation is if there are two at symbol after, before versioning, after API name, that means the default one. So if I compile my application with this one, it will use this version. And the ones with the single add are the older version, and we can have as many as them. So it's not limited to two. The benefits, we can update library codes without breaking ABI. So DPDK developers doesn't have to wait for the next LTS release. Problems, it produces a little more code maybe, and that's not, it creates some clutter. So that needs to be cleaned up in next LTS, but that's a drawback. And as far as I know, there is no Windows support. That can be another When the function fingerprint has changed, like if just the parameter type change, return type change, those kind of things, it's straightforward. Just you will have a new version of that API, and that's done. There are a few DPDK macros. We will define them, and that's all. It is a little challenging if data structure is changing, and I think we are hitting that more. We are using a configure struct, for example, that is changing, which having a knock-on effect on many APIs because multiple APIs are using them. And if that struct is nested within another struct, then every user of that other struct also needs to be versioned. So based on what is changing, it may end up updating multiple functions, creating new, and of course, new version of data structure as well. I have very quick, simple sample as well for that. So in our for example, it was generating a wrong output. So this is how we can fix it. What needs to be done is, indeed, is really not magic. There was a for function. It was getting 2 parameters. It became now another name, for_v1 in this case. The new API, this is the change I want to have. It become for_v2. So okay, I have 2 different ones, but eventually application should find this as for. So because that's why what application calls. This firmware pseudo-op is the way to provide it. This is doing all the magic. So it just says my for v1 is now API 4 with the version tag v1. And for v2 is API 4 again, but this time version v2. And in this example, it is selected as a default one. Again, you can just select whichever will be the default one. Because now you have your version tags, you want all APIs, even you are not using the ABI versioning, to have some kind of version tags attached in all APIs. And that is done by linker scripts. In DPDK, we have for them for each library already. And its syntax is, there is a version label, global, and this is the list of exported APIs. There can be a bunch, and catch-all is the local statement. They are local. There, it is possible to have multiple of these. So in this case, for will be marked both as a v1 and v2. So that is mainly all you need to do if the function fingerprint is changing. And yes, firmware is overwriting what you have in your linker script. That's why in DPDK, if you forget to update your linker script, you should update linker script as well when an API is added. And we are using that a little more extensive with the internal and experimental API tags as well. So after those changes, what happened? Now lib4, again, if I check with readelf, has displays 2 versions of for. And I compiled main with lib4. And I check main, and yep, I verify it is using for v2 because this was the default, so this is selected. And the old application I compiled with for v1, I'm running it, yeah, it's for v1, and when I run it, it gives the correct results. So same application gives 2 different results, but because they are using 2 different versions in the same library. So that for API fingerprint change, this is all needs to be done. That's for how we are doing is DPDK. This firmware is wrapped with some macros. So version symbol is a macro. Next slide, I will show a little more detail. But it is just a firmware bind default symbol, same thing, but with 2 adds. And map static symbol, I will touch later as well. This is just cast to used attribute. That is, make sure the compiler may think it is not used and compile it out, but we are saying no, that API is required, so it will keep. In DPDK, each API has @DPDK underscore and our ABI release information. And that they are coming like, the latest one is DPDK 24, I think. That is, with this 2011 release, we are in the cycle of ABI, major ABI release 24. That's why the version scripts are updated, so new APIs will have this tag. If you don't have any ABI versioning, by default, every API in the binary form will have this tag. Yep, these are, okay, sorry, hard to see, but directly I get copy-paste from this file, RTU function versioning.h, you can see from there. But the version symbol, simware, and it just detects our ABI version, dpdk underscore dead. Version symbol, experimental, let's skip that one. Default symbol, same thing, double add, and vsim is RT-used. There is static one, again, I will come for it. This is from Git history. That's already done at some point. And this is a ABI versioning sample. It seems it is done with telemetry data array because it is parameter is changing from int to int64. And that's how it's done. There are two versions of functions now. Version symbol 23, default 24. This will be the API that application will know. Also, static alias is added. The version, the linker script is updating like this. There was already 23 and the API. Now 24 is added, and same API is added. In header file, what should be? Since default one will be the latest one, a header should have the latest API, because all applications are binary, right? So they won't able to use, they don't need the header, the new one does. So this is, again, readelf output. We can see there are two versions of it. When data structure needs to be updated, it is a little different because here we have the structure and a very simple function, main is calling it linker script. This is pretty much same thing. But I decide I will add int a in the beginning. So what is required? I will skip this a little quickly so that I will able to let time in the last. But when this is added, header will have new version. I can move the previous one in the C file because now no public application will use it. But it has a version tag. Again, functions has a version tag. Old one is using old one. New one is using public one. Added simware, updated version script, and function is changed. Again, voila, it works. This is what needs to be done for structures that add a versioning to the structure as well. I mentioned about this macro we use in DPDK, map static symbol. Since we are updating function names like v1, v2, but application in the static build will need the function for example, then how it will find that function? There is no that function, so this creates just an alias to the existing, to one of those functions to the for, like for v2 will become for with this alias attribute. And we should use the default symbol for the static because new applications will use that one. The conclusion, this is a useful tool. It is out there for a while. We have an ABI compatibility concerns time to time, and we stuck with updating it for next LTS release. So let's give more try. As I said, there are already samples, but this can be done more. So this is just a suggestion to use more. Hopefully, those references, simples, like these are all ABI versioning commits in DPDK. They may help. So I would like to discuss one more thing before leaving, again related to the ABI versioning. In DPDK, we have already a macro called RT-next ABI that is already documented in the process. We have ABI process documentation, by the way. It is in the backup slides for anyone interested. But this is documented but not used at all as far as I remember. The idea is whatever requires ABI breakage, let's add them in DPDK release with this macro so that it can be still in the release, it can be still visible. Of course, it won't be enabled because it will break ABI for other users, but can help including your ABI breaking chains earlier. What does it make sense? Why we are not using it? Should we use it? I propose using it, but that's the another point. It helps if we can get an agreement. There are small things needs to be done to support it, but none of them are, I think, big thing. I try to list what I can come there. Like since it's a new code, new testing requirements can come there. And we may have some automated checks to remove them at the LTS, but none of them are big thing. Does anyone see any objection? This has been talked in the before, indeed, that's why it's in the process document, but if anyone doesn't have an objection, why not use it? Is my final statement. Anyone can think of a bad thing because of using this one? Okay, that's one option. That's all. Thanks. Oh, sure.
Two things. If it's enough that one change basically will break the code, right?
Yep.
So it should be either mandatory to do it, or if we're partially doing it, we're not doing anything. Am I correct?
Again, please. No,
I'm saying that if we're doing it only on partial and it's voluntary, then it's useless from application point of view because they cannot count on it.
This API.
No, not this one, the previous one. The
application can rely,
API versioning.
Yeah, can rely on it because they will able to use the existing ones.
No, the other way on. They can they can rely on it only if we promise them that any change is doing it. So
I disagree. No, I think it helps to utilize it more. Doing more helps more to users, or may helps to vendors because they put things in early. But no, it doesn't mean we always have to do that. A vendor or whatever developer can say, just breaking ABI, I won't do this now. That's also an option, I think. It doesn't have to be done always. Well, why do you think? Please explain.
No, I'm thinking that if you're doing it, just make sure. I'm talking about the ABI
symbol versioning. Yep.
Symbol versioning. So basically, if the application cannot count that the symbol versioning is valid, okay. And for example, you did two API changes.
Yep.
Two ABI changes. One, you did the change, you marked it correctly, you did the versioning correctly, and the second one you didn't. So from application point of view, it doesn't know which one you did or if you did that, so it cannot count on it.
Not like that. This is transparent to application. When I do the ABI versioning, application will just continue to use a new one. It won't recognize that I'm doing new versions. But if I don't do the ABI versioning, since it's ABI breakage, the change won't go into DPDK, so application won't be able to use it at all. Yep.
Okay, but then you're talking about the new define that you're talking about, not ABI versioning as
so this is something else. Yeah. This is something else than ABI versioning. We can think later as well. Thanks again.